Okay, everybody, here we are. Pretty much it's our last module. There is a module 14, but we don't have any quiz or anything for that. It's mostly a review of the year, and we're going to do a project with that one. That'll be a class project where we make something called the Rube Goldberg machine. It's a lot of fun. We set it up and try to make a little simple task take place. It's a little kit that I have. So, so let's see what we're ending the year then. The topical stuff we're going to be talking about would be environmental science. Let's get a little introduction. This is one of those videos that doesn't have anybody talking, but there's a little bit of, words you have to read. So. So, we're ending the year talking about living things, and so we're going to look at the different areas where living things are. Okay, so we're looking at their ecosystems and things like this. All right, so at the beginning, at the top of your chart here, you're going to have these recollections about the types of symbiosis. We're going to review it. All right, here we have clownfish and a sea anemone. What kind of symbiosis is that? Mutualism. Then we have the barnacle on the whale. Barnacle doesn't hurt the whale. What's that one called? You're going to write down mutualism in that first box. The second one's called commensalism.
Do you have a pencil I can use?
I do. So that barnacle and whale, commensalism. This is review. And the last one, parasitism. That's a lamprey on a fish, right? It's a parasitic relationship there. The lamprey benefits, the fish dies. All right, so we have them. Mutualism, commensalism, and parasitism.
They have us say the actual, not the kinds, but the...
Oh, it tells you what kind? Oh, okay.
Yeah.
So that's barnacle on a whale, that's lamprey Lampreana fish. I had that backwards, sorry. So you had the bigger words written down already? That's good, because I didn't put them up there for you, therefore, with spelling and whatnot, you know. All right, so that's a review of module, was it the previous module, or was it just last week that we talked about that? That was just last week, right? Okay. All right, we're going to review now the cycles that we find out there in the world. We call them the ecological cycles. These would include the carbon cycle, the phosphorus cycle, the nitrogen cycle, the water cycle, and the oxygen cycle. All of these are like recycling projects, and so we're just going to write down a little something for each one of these. Well, for 3 of them, I think, right? So under hydrologic cycle, the water cycle, just write water gets moved, cleaned, and recycled. So those are all our shuns, right? Evaporation, condensation, precipitation, percolation. What was yours? Evaporation. All right, we got a little something there. Next one, the carbon cycle, CO2. Just make sure and put CO2 gas needed for photosynthesis and greenhouse effect. So remember, CO2 is not the big bad wolf, right? It's not the big bad enemy. Too much of it can be a problem. I understand. All right, remember we can see how it's recycled in many ways right here. We can see that decomposition, of course, down here under the ground. We put CO2 into the air with sometimes with pollution and things like this, but also organic carbon can be released into the atmosphere through with plants and animals. There's an animal, us breathing, you know, exhaling, right? All right, the nitrogen cycle, N2 gas, essential, just say gas balance and plant nourishment. It's like vitamins for plants, really. So once again, I think I mentioned how my garden grew really well with all the leaves growing lovely because I had a lot of nitrogen in my soil, but they didn't make a lot of fruit. So if you're growing leafy plants, spinach and lettuce and stuff like that, nitrogen's great. But you want to watch out for your balance between nitrogen and potassium, called potash, and other minerals to get good flower and fruit production. But we need the nitrogen. Remember, nitrogen gets recycled in various ways. There are bacteria that live in the soil that fix it. Lightning strikes will make it usable, and other. We see lightning right there, yeah. Okay. See, tell me if the blank is correct in your book. Does it say this? Biome is the term used to describe where organisms live. Mm-hmm. Okay. I had to fix that because we had a different sentence in there yesterday. My book is different from your book, is the bottom line. So I got it changed because it's confusing what you were supposed to write there. Okay, so what do we know about biomes? Who made a biome model for me? You did, right? It was the Arctic tundra. Did you do one? You never did one because you just skipped that. I think you skipped that particular grade right there. It was one of those fun projects my students find pretty memorable. They make a box, you know, with the little animals and everything that lives in the particular biome. So biomes of the world, they're areas where similar plant life, animal life, and climates are. All right, and I think there's a blank below that says list biomes. Let's skip that for right now because you're going to list them down in the box at the bottom of the page. So you can leave that thing blank right there. Notice what I have over here in this little cake-looking thing. I have different slices. We can see ocean right here, tundra, forest up at the top, grasslands. Here's the orange piece right here is it looks like a savanna of some sort. The top green one is a coniferous forest. We also have deciduous forests. Those are trees that lose their leaves. And so in each one, so around here, we're pretty much, our biome that we live in is pretty much a deciduous forest. We live in a lot of trees around, and the kind of trees we have lose their leaves, unless you live out there in the Tahitian area where we have pine, right, lost pines. So we have maybe a coniferous forest there. So the animals living there might differ than the animals just living down here in Cedar Creek, right? Because of the different kind of trees we have. And the reason it makes such a big deal is that the needles that drop off of pine trees are very acidic, and they make the soil more acidic. Therefore, different kinds of plants grow out in Tahitian Village that I cannot grow in Cedar Creek. And my soil's not acidic enough. So it's kind of interesting how we have just that little change makes such a big difference. All right, we have levels of organization out there where we start with a biosphere, and we'll get to that in a second, and then the biome. So let's put a biome in here that's not there. We have an ecosystem. It looks like we're looking in the ocean right here. We have kelp, we have sea otters, we have sea urchins. Then we have a community. What are the living things? Oh, we have temperature, water, salinity, all that stuff, the niche that everything is filling. Here we have the community of the living things in that area, right? Population, the living things of one particular group, and an individual, the individual of that group. That's the way we're going to classify all these creatures in this region. Within the biomes, there are ecosystems where communities of organisms live. So ecologists are the scientists who place organisms into ordered grouping so they can better understand how they live and interact. And the complexity of these systems is massive. In fact, sometimes it's hard to kind of pin down a particular biome because it might have mixtures of some, okay? But we can give it a general idea. So generally, in the Bastrop area, we live in a coniferous and deciduous forest. So here is a biome or an ecosystem. Where do you think we are? Where are we in this picture? Say again? Where? Where would we see this scene? Hint, we are not at a zoo. Where are we? I look out my hotel window and I see this. Where am I staying?
Would there be a hotel out there?
Maybe. There's a famous one that's up in the tops of the trees. It's called the treetops. It's Africa, y'all. We're in Africa here. Yes, right? Y'all all knew that. You're just not speaking out. So that would be Africa, where we're going to see these different creatures here. Notice we have lions over here, and I guess you already know that there are no tigers, right? Tigers are not in Africa. Tigers are in India. Yeah, and there are no lions in India, just tigers. All right, a species is a group of organisms that interbreed to produce offspring. Okay, so the way we define a species is, can they reproduce? All right, so for instance, if you had a Chihuahua dog and then a big Dane, a Great Dane dog, right? They're both still dogs. Can they reproduce? Yeah, they can. But if you have a dog and a cat, can they reproduce? No. All right, so we have a species of dog, a species of cat, and within the species we have all sorts of, variety, in there. All right, so a species, we divide community into breeding species, so if they breed, and typically if they breed naturally, so not something we're forcing. So typically with dogs, we kind of, keep dogs, we don't breed a Chihuahua to a grade, we don't do that. Right, if it happens, it's accidental and I don't even know how they manage it. But we tend to breed golden retrievers with golden retrievers, right, and that's natural for them to do that. So we call that a species. Here we're looking at some meerkats right here. And then the organism within the breeding population is the single organism. There's our little baby meerkat, so cute. So all of this is just a way that the scientists, group things so that we can have a better understanding of the way they fit in their ecosystem. All right, the biosphere describes the whole Earth. That's the biggest thing. I guess you could say the biggest thing is the universe, right? And we are in our local group, and we are in our solar system, and we are, in our solar system, and then we are in the Earth, which is the biosphere. And bio meaning, of course, the things that are living there. So let's take a look at some of the biomes real quick. So I'm going to have you list on the bottom in that chart. We're going to list some down here. All right, first one, rainforest. So write rainforest in box 1. So in the rainforest, of course, we see lots of greenery, lots of rain, lots of variety of animals. Probably there are actually insects in the rainforest that haven't been identified yet. There's so many of them that are still, if you want to go discover an insect and name it after you can go to a rainforest. Next comes the tundra. Frozen most of the year. They have a very short summertime, but most of the time they're dealing with cold. We have the grasslands, which would include the savanna grasslands and the prairie grasslands. So we can divide those into two. The savanna being the one we find in Africa and Australia, and the prairie the one we find in America. We have deserts all over the world. We have the forest also broken up into the two. We have the deciduous forest and the coniferous forest. And the largest of all of them would be the ocean. So I've named 1, 2, 3, 4, 5, 6.
There's 8 boxes.
There's 8 boxes. Let's think of another one. Can you think of another one? We could have broken those grasslands up, I guess, into savanna grasslands and prairie
That's what I did.
grasslands. That's what you did? Okay. Because I don't know.
That's what we did
Think of
for
them.
the projects, I think.
Yeah. Am I leaving any of them out? I don't think I am. Yeah, so that's okay if you have just in one of the, you can draw an arrow saying deciduous versus whatever. If you want to, you don't have to. The tundra is one of the coldest and driest, interestingly, of all the biomes. Largest biome. Tundra means treeless plain. Much of the area is considered permafrost. That means the ground is frozen all year round. Even if there's not snow on it, the ground is frozen. And so if there's frozen ground, it makes it difficult for plants to grow. There are no real trees in the tundra area. Animals include reindeer, polar bears, seals, caribou, foxes. Plant life includes shrubby grasses, lichens, those are all very low to the ground, small shrubs. The tropical rainforest. Tropical rainforests are located around the equator typically, where it's warm and humid all year long. Animals include snakes, insects, tropical birds, amphibians, those would be frogs and stuff like that. Mammals like monkeys. Plants include very large trees, tropical flowers. What does that last one say? Oh, like orchids. Orchids grow in the rain. And they form this giant canopy that covers the top of it that makes it actually kind of shady if you're walking around inside a rainforest. The savanna, here's the African savanna. We can see scattered trees. The savanna has less rainfall than like a forest area, but more rainfall than a desert area. All right, so we have this kind of savanna found in Africa, and we have the Australia biomes that includes the Australian savanna as well. So we have a subtropical up here to the north, and right up here in the northern part, subtropical. We have desert in the middle. We have forests and woodlands here, and grasslands and savannas over here. So we're going to be looking here. This would be part of the desert area. The smack middle of Australia is a desert, and it has red sand. This is called Ayers Rock. It's very famous for opals. Do you know what opals are? A precious stone. Very beautiful. They mine them here in this area of Australia. And of course, we would see animals like that, right? So very unique to the area. All right, ecological succession. This happens when the environment changes and new plant or animal life will move in. So this happens sometimes. It'll happen when there's been a tragic event. For instance, we experienced that in the Bastrop area about, I think it's now 11 years ago, that we had a fire, and the fire burned down vast areas of the piney woods forest out there on the other side of Tahitian, but it did jump the highway, and I know people who lived in the Tahitian village area who lost everything. Well, their home. They didn't lose their lives. So when all that stuff burned down, it was actually kind of fascinating to watch how quickly it recovered. We did plant some new trees, but some of the trees came back naturally, and then some trees that weren't there before now came back. So brand new types of trees. In other words, where pine trees were growing before, now we have deciduous trees growing there. And something really interesting about the soil. All that stuff that burned, it got into the soil, and they call it biological char, and people are selling it. I can get it from my garden as a type of compost, and it's supposed to be and it's literally Bastrop char that they're selling. And I'm like, well, I could probably just go dig around, right, in some of those areas that burned down. So it's quite amazing the resiliency of the earth after something bad happens. All right, so, but it also happens, let's say for whatever reason, we're going to look at a specific case of that here in just a second. The video we're going to watch is kind of like a volcanic eruption that kind of forms a new landscape, if you will. We start with nothing, right? As time goes on, life always wins. Life always wins. It comes in and it prevails, and it is robust. All right, so I think God made it that way, that life would always win in the end. All right, so we're going to watch this video of some people looking at the stages of primary succession, I believe in a volcanic area.
Ecosystems are shaped by biotic and abiotic factors. But before biotic factors like plants, animals, and fungi can become established, we need abiotic factors like sunlight, rainfall, and nutrients. And today, I'm here with ecologist Joe Mascaro, and he studies how ecosystems change over time. And Joe's going to help us understand how we can start with solid rock, and through biotic and abiotic factors, they can change this rock to support life. So let's track the stages of primary succession by visiting lava flows of different ages.
So, Suze, this is the earliest stage of succession, where the rock's been colonized by lichen and some small sword ferns. These guys will colonize lava right away, almost the day after it cools. And once they do, they'll begin the soil formation process. So they'll grow, and they'll start to break apart the edges of these rocks, which are really friable and easy to break. And then the lichen will fix nitrogen from the atmosphere, and that will begin to build up soil on the surface of the rock.
Now let's move to the next stage of succession, one that's a bit older.
Well, Suze, this flow looks like the ecosystem has developed a bit more than the last flow. So you can see how there's so much more lichen than there was in the previous flow. It's almost like a carpet. And as the lichen grows, it's basically breaking up the surface of the rock and starting the soil formation process, which is really happening in earnest now compared to the previous flow.
The first plants that become established are early colonizers. Early colonizers have other characteristics. They're fast-growing, they need lots of light, and they're usually wind dispersed.
That's right. And there's basically two types of early colonizers we might see on a flow like this. There's some that have a symbiotic relationship with fungi, and so they're able to fix atmospheric nitrogen directly and use it immediately. And then there are plants that are just able to tolerate really low levels of nitrogen, like ohia.
Okay, off to the next stage. So here we have an even older flow.
So we're actually going to see quite a bit more soil here than we saw in earlier flows. And we've really got a lot of moss. So we're really starting to see the ohias come together, and we're getting much closer to a closed forest. We're not quite there yet, but you can see how much taller they are and thicker.
Off to the next flow. So this is what scientists would call mature forest. It's over 300 years old. It might be hard to imagine, but this whole area was once barren lava rock. Let's go check it out.
So, we're definitely in a later successional forest now, which means we're dealing mostly with tree species that are not wind dispersed. They typically have big roots, maybe dispersed by animals. They're much slower growing, and of course, they tolerate shade. And as a result of all those features, they tend to need a lot more nutrients over time to grow.
All right. I wish they'd given us a little more idea of how long it took to get one once it staged to the other, right? I guess it depends on many things. But at the end there, it said we were looking at 300 years, right, before. All right. In your book, it talks about this awesome event that took place on an island called Surtsey Island, just off the coast of Iceland. And in 1963, a volcano started erupting in the ocean, and before they knew it, within the year, less than a year, there was a new island that had formed just out of nowhere. So while you're looking at the ocean, nothing there, all of a sudden, boom, there's an island. So it's about 60 years old, which is very young when you think about the life of an island, right? It was only 60 years old. So when it first formed, of course, it was very hot because all that lava was out there. And so as it started to cool off, people went out to the island. They took little boats out to the island, and they noticed some things growing pretty quickly. Now, he mentioned in the video lichens. Can we talk about lichens? That's the stuff we see it all over our trees here. It's not a parasite. I think it would be considered commensalism versus mutualism. I think it doesn't hurt the tree at all. When you see that growing on, you think, oh, that's bad for the tree. No, it's fine for the tree. It doesn't bother it. What it does, though, the tree has bark, and the bark has water that can collect in it, and these guys can soak up that water. So that's what lichens do. They're actually a mix of an algae, and a fungus that work together. Yeah. And so those come first. In fact, in the video, he said by the time it's cooled, there's lichen growing. Where did they come from? Where do you think it came from? How did it get there? A couple of options. What'd you say? It's floating in, that's an option. What's another option? There's wind. Could have blown in. Could have combination of blowing and floating, right? It somehow could have been ancient stuff inside the lava that burst out. Don't know. I think probably the floating and wind bringing in is probably the best idea there. All right, so then they started to keep track of what was going on as far as life was concerned. I believe there are people who took these pictures. That looks like something they've set down, doesn't it? That looks almost like trash or something. That's another thing. Trash can show up from floating in from waves, sadly. All right, but as time went by, here are some people going around. Look at the grass is growing there now, and they're actually catching butterflies. Okay, so insects show up. Because where there are grasses, there are flowers. Where there are flowers, there are creatures that want to eat the nectar of the flower. And as a little more time went by, they became very famous for their puffin community. I think there's parts of the area that have pretty high craggy cliffs, and the puffin likes to live on craggy cliffs. It flies. It looks a little bit like a penguin, but it's a flying bird. Penguins are not, of course. But it flies and collects. A lot of times you'll see them with fish hanging out of their mouth. Collects food for its little babies that live on these little crags of these cliffs. And you may have seen it before. It's some of them falling out. Have you ever seen videos about a bird falling down the cliff? It's pretty funny. So a lot of times it's puffins, and they're fine. They usually end up in the water and they're okay. Just kind of get out of the nest kind of a thing for mama. All right, so that was showing you how that succession can happen reasonably quickly. In over just 60 years, we have pretty good life forms on Surtsey. All right, what about us? How are we supposed to take care of our planet? Is it important for us to be responsible and take care of our planet? I would say absolutely that's important because God told us to, right? He said, I need you to be good stewards. That means take care of this beautiful planet I gave to you. Does it mean that we worship nature? No, we worship the guy who made it. That would be God. All right, so human impact on environments can be good or bad. All right, there were times when we didn't give it much thought, didn't think what we did really affected the environment, and in some large case scenarios that might be true. But in small case scenarios, do y'all like seeing litter along the highway? I hate that. I don't like seeing litter along the highway. People throw stuff out their window. That to me is, they should get a ticket for that. I think they can. If a cop saw them do it, they could get a ticket for that. All right, we're going to watch a little video. Now, this is maybe a little controversial. The idea is that in the effort to be conservationist, to conserve what we have, to take good care of our environment, some people have decided that we can't do certain things. For instance, it's evil for me to drive a car that burns gasoline. That's what some people would say. All right, and so the question is that true? You know, do I need to feel guilty about driving a car that uses gasoline? You know, some people say the answer is, of course, battery-operated vehicles. But if you look into the environmental impact of making the batteries big enough for a car, it's about the same. There's not a whole lot of gain environmentally. So this is a guy who's going to be talking to you about how he was an activist and how he learned some things and has made some changes in his mind.
Just because you feel like you're doing the right thing doesn't mean you are. I have dedicated most of my life to protecting the environment, but I went about it in the wrong way. I thought I was acting morally, protecting the well-being of people and the planet. In fact, I was harming both. I believed solar and wind power were the future, our only hope of avoiding an environmental catastrophe. Fossil fuels were the enemy, extracted from the earth by greedy companies plundering the land, polluting the air, and destroying ecosystems. Keeping the wilderness as pristine as possible was my passion. Ever since I was a teenager, I've loved the outdoors. I led mountaineering expeditions in Alaska, spent months backpacking in the Rockies, and climbed the highest peaks in national parks. I only took jobs I thought would protect the environment. I started a company that built composting systems for cities and businesses. I served as executive director of an organization that championed green construction policies. And then I became CEO of a consulting firm that worked on making homes more energy efficient. At that time, the Obama administration had earmarked billions of dollars in federal funding to create jobs in the energy sector. And my company won multi-year contracts valued over $60 million. I thought I was making a real difference in the world. I was surrounded by smart, successful, and ambitious people who shared my beliefs and my heartfelt desire to change things. And my company had lots of money and lots of government support. There was only one problem. Our project to build more energy efficient homes was an utter failure. Making home energy improvements was much too expensive for middle class families, even with generous government subsidies. Wealthy families, by contrast, loved the program. They got subsidies they didn't need in the environmental cred they craved. In reality, though, we weren't achieving much of anything, except wasting taxpayer money. That's not how the government saw it. The government celebrated the project as a big win. It was a great photo op for politicians, but I knew the program didn't deliver the jobs and energy savings we had promised. Maybe I should have accepted the props and kept doing what I was doing, but I couldn't. I began re-examining everything I'd believed about energy and the environment. It didn't take me long to realize that I had been living in a fantasy world, perfectly fine for making me feel good about myself and my mission, but perfectly useless for making real environmental change. The more research I did, the more I realized that my project was just a symptom of a much bigger problem. We're wasting trillions of dollars on the false hope that wind and solar power are going to replace fossil fuels, oil, coal, and natural gas. Yet, over the last 20 years, the world's dependence on these fuels has declined by only 3 percentage points, from 87% to 84%. That's a pathetic return on our investment. If we're serious about confronting climate change, protecting the environment, and helping people climb out of energy poverty around the world, we need to stop chasing fantasies. Instead, it's time to honestly examine all the costs and all the benefits of every energy source: wind, solar, oil, coal, natural gas, and nuclear. Greenhouse gas emissions are a concern, but not the only thing we need to consider when discussing energy and the environment. Here are 5 principles to help us evaluate the best energy options to protect both people and the planet. 1. Reliability. A reliable energy source provides power 24/7, 365. States and countries that have doubled down on renewable sources face energy rationing and power blackouts. 2. Affordability. The cost of energy affects the cost of everything else. If energy isn't affordable, ordinary people can't heat and cool their homes, and businesses can't make the products we want and need. 3. Security. Controlling access to critical resources needed to produce affordable, reliable energy is essential to national security. Over-reliance on energy imports or minerals from other countries puts our nation at risk. 4. Scalability. Wind and solar resources are usually located far away from where people live and work, making it difficult, expensive, and inefficient to transport energy to where it's needed. Fossil fuel and nuclear power plants have safely operated for over a half a century within city limits. 5. Land use. The more land we need to produce energy, the more wildlife habitat we lose. A typical 1,000 megawatt nuclear power plant needs little more than 1 square mile to operate. Solar farms need 75 times more land to produce the same amount of energy. Wind farms need 360 times more. I'm still devoted to protecting the beautiful landscapes I fell in love with when I was a teenager, and I'm still committed to raising living standards, reducing pollution, and lowering greenhouse gas emissions. All these goals are achievable, but only if we're realistic and practical. Wishing won't make it so. I'm Brian Gitt for Prager University. Thank you.
Okay, so he's making some points, and the points are, first of all, I would consider myself an environmentalist. I have literally hugged my trees, because I'm praying that my tree doesn't die, right? So I love the creation that God has given us. The problem is we've turned it into something we call political. I know that sounds a little boring right there, but political means that I'm going to like bludgeon people if they don't agree with what I'm saying, right? So if you don't agree. So this guy was on that side who would have been saying, you shouldn't drive your car, this kind of thing. And he did some research and figured out, oh my goodness, it's not that bad. First of all, secondly, they're trying to scare us all. That the planet is going to boil away and we won't have a planet left, okay? That's called, in my I would call that eco-terrorism. They're trying to scare you. Okay, so God's got it. Don't worry, God's taking care of the situation. I had a student one time who was doing the English class. We used to call it English 5 back in the day, where they had to do a thesis paper and do. I mean, it was a big deal, and they had put a presentation at the end of the year. Well, his thesis was that nuclear power was bad for the environment, and we should get rid of it. He went and did his part of the research was taking the opposite view, and looking up research to say it's really good, right? And when he did all that, he changed his thesis to saying we should go to all nuclear power because it was that good. Okay, so we just need to do a little research and don't necessarily believe everything people tell us, including me. Okay, you don't have to believe everything I tell you, except for the quiz, right? Just for the quiz, you need to know what I said. All right, but people do have a responsibility to care for and manage the earth that God has made. I absolutely 100% agree with that. And I've done a few things, personally. I've stopped using water bottles, for instance, although, look, I still use plenty of plastic. I try to recycle it and use it over and over again, just for my science classes this way. Also, composting, right? We're going to look at these guys here in just a second, see if anything has changed in there.
Are they live?
Yeah, I think so. They all dug down to the bottom. I gave them a little water, some newspaper. So why do I want to do composting? Is it so I can save the planet? No, it's so I can have really great soil for my garden and grow some good stuff, right? So in other words, if I'm selfish about it, I can still do something good, right? I don't have to be a crusader out there. We'll look in a minute about plastic. And I am trying to, like we put food in plastic containers and stuff. I'm trying to move away from that. So I like my lunches in a glass container, metal containers, So I'm just trying those little tiny steps to take. All right, so what are some of the negative human impacts? You're going to write these down in those little, I think, is it boxes or blanks? Boxes?
Boxes.
Okay, number 1, pollution. All right, so when we're talking about that power, making that power plants, we will also produce some pollution, which can, of course, have a negative effect on the environment. Number 2, trash, littering. Especially, we're seeing a picture here of the trash that ends up in the ocean. Oh my goodness, awful. We're going to see on the video here in just a second about that. Deforestation, cutting trees down. All right, do we need to cut trees down sometimes? Yeah. Probably you have a house built with wood, and the wood came from trees. Okay, but here's the deal. A person who runs a forest to make wood for houses, guess what they want? They want more forests. So guess what they'll do? They'll replant. The problem is, it takes time to grow, right? It takes time. So we have to make sure and keep replanting and stuff like that. Next, we have, drilling for oil in areas that might be sensitive. This shows an oil rig out in the ocean. The oil rigs in the ocean are great because they can reach down below the surface. In Texas, if you go to the Texas coast, you'll see them, especially at nighttime, because you can see the lights blinking. In the daytime, they're way out on the horizon. So they don't really bother beachgoers that much. That's one of the reasons they go that far out, is so that because people at the beach don't want to see it, right? And so we move it out a little farther. Question?
Like whenever you go on when you're going to Port Aransas, like you'll see like a bunch of those, and they'll just like move.
Wait, they're not moving. No, unless you're seeing a ship go by.
Yeah.
Ships, there's at Port A in particular, they're coming into the port, and so those giant ships will go by, and they may be tankers, and they're massive, right? Those are ships. But if you look way out on the horizon, you can see, and it's like I said, at night the lights will be shining. It's a platform. So that platform right there is permanent. And when everything's functioning okay, it's great. There's no problem. But guess what happens in the Gulf now and then? Hurricane, right? A storm comes in, and sometimes it can cause the oil that's being pulled out of the ground, like a pipe to break or something, and the oil's released into the water. Okay, and that's not good, right? It'll float to the top, but it's hard to clean up. Birds, if they land in it, get it all over their feathers, and it kills them. It's awful. But we try really hard not to have accidents. Of course, we want, we want to get the oil to the people, not to waste it. Next would be, this is called dredging. So just dredging would be when we go and just dig a big hole in, and that's happening at Port A as well. And the reason they're dredging there is to make sure those ships can still make it in. Okay, because the bottom gets shallower because deposits come and form there, and then the ship could get stuck on there, and that would be bad. Here, I think they're just showing the dredging, and they, I'm not sure exactly what they're doing with it, but it's dredging. Here, overfishing. Overfishing is another negative impact of humans. Sometimes some fish that are very expensive, for instance, probably because there's fewer of them. Okay, we're going to do kind of ecological study of that with our lab here to talk about, and it's going to specifically be about fish and birds. Did you fill in all the boxes then?
Yeah.
The negative impacts? Okay. Improving negative impacts. Here we go. Replanting trees. People who use wood for a living will do that for their own interests. Remember, selfishness is not bad if it's going to end up benefiting the environment. Using biodegradable products, right? Things that will compost more easily. Have you seen those paper plates and even paper, not paper, but forks and things made out of cornstarch and stuff? They'll dissolve over time. They make paper out of corn and it dissolves. Paper plates. Some of the paper straws, right, instead of plastic straws. Some paper straws are okay. Other ones almost dissolve while it's in your drink, right?
Yeah,
it's no good. Trash pickup. Okay, so I noticed in my neighborhood a new sign up that says, trash pickup sponsored by such and such business. And once a month they put a call out to the community and say, hey, if y'all want to come out, I have a vest you can wear and a bag and a pincher, and you pick up trash in that particular spread of the road. Decreasing plastic usage. And then I have 2 blanks there. Y'all can think of anything. Can y'all think of things to make the environment better? Have you put much thought into it? Is anybody out there an environmentalist? Any of y'all? Think that it's evil to drive a car that uses gasoline? No way? Okay. I don't know if I'll ever give up my internal combustion engine. I don't want a battery operated car. I don't want the government to make me have a battery operated car because I am an old dog and that is a new trick. All right. I just like the way I've done it. I also don't want a car that drives me. You know what I mean? I want to drive myself. I don't want an automatic drive. I don't mind getting on a bus or something like that, but not a machine. All right, conservation is the preservation, care, and management of our natural resources, balanced, I like this, with the needs of humans. All right, we shouldn't leave humans out of this. We aren't the bad guy. All right, we're the good guy. As long as we're taking care. Are there some people who are abusing the environment and making terrible messes? So yeah, sure. But I think they're few and far between. Don't you think if you asked people on the street and say, is it important for you to drink clean water? Don't you think most people would say, yes, that's important to me? Right, it's kind of nonsensical to think that somebody would like, oh, let's have dirty water and dirty air. There might be some people who are making a buck off it or something, they're just bad. What are some good ways to manage Earth's natural resources? Like take care of the needs of its people? Let's check this one out. What do you think about recycling? Do y'all have a recycle bin at your house? I have I live out in the, I guess you would call it semi-rural. It's on 5 acres, but it's not a farm. I've got neighbors, this kind of thing, but it's not a neighborhood. So semi-rural. And my trash company said, yeah, put your recyclables in here, and then So every week I would take my plastic and put it there, my glass, and put all that stuff. And then we went down and sort of spied on the trash company when they came. They all threw it in the same part of they just threw it right in the trash truck. So they were not honest with me about recycling. So I said, why go to all that trouble to do that? And so what we'll do now, and maybe you've done that. Have you ever collected aluminum cans? And you can go get money for them, right? You can get paid for that. That's a particular thing that recycles very, very easily. Paper recycles pretty easily. Some plastics, not all. All right, so let's watch a little video.
This is the story of 3 plastic bottles, empty and discarded. Their journeys are about to diverge, with outcomes that impact nothing less than the fate of the planet. But they weren't always this way. To understand where these bottles end up, we must first explore their origins. The heroes of our story were conceived in this oil refinery. The plastic in their bodies was formed by chemically bonding oil and gas molecules together to make monomers. In turn, these monomers were bonded into long polymer chains to make plastic, in the form of millions of pellets. Those were melted at manufacturing plants and reformed in molds to create the resilient material that makes up the triplets' bodies. Machines filled the bottles with sweet, bubbly liquid, and they were then wrapped, shipped, bought, opened, consumed, and unceremoniously discarded. And now here they lie, poised at the edge of the unknown. Bottle 1, like hundreds of millions of tons of his plastic brethren, ends up in a landfill. This huge dump expands each day as more trash comes in and continues to take up space. As plastics sit there being compressed amongst layers of other junk, rainwater flows through the waste and absorbs the water-soluble compounds it contains, and some of those are highly toxic. Together, they create a harmful stew called leachate, which can move into groundwater, soil, and streams, poisoning ecosystems and harming wildlife. It can take Bottle 1 an agonizing 1,000 years to decompose. Bottle 2's journey is stranger, but unfortunately no happier. He floats on a trickle that reaches a stream that flows into a river, and a river that reaches the ocean. After months lost at sea, he's slowly drawn into a massive vortex where trash accumulates, a place known as the Great Pacific Garbage Patch. Here, the ocean's currents have trapped millions of pieces of plastic debris. This is one of 5 plastic-filled gyres in the world's seas, places where the pollutants turn the water into a cloudy plastic soup. Some animals, like seabirds, get entangled in the mess. They and others mistake the brightly colored plastic bits for food. Plastic makes them feel full when they're not, so they starve to death and pass the toxins from the plastic up the food chain. For example, it's eaten by lanternfish. The lanternfish are eaten by squid. The squid are eaten by tuna. And the tuna are eaten by us. And most plastics don't biodegrade, which means they're destined to break down into smaller and smaller pieces called microplastics, which might rotate in the sea eternally. But Bottle 3 is spared the cruel purgatories of his brothers. A truck brings him to a plant where he and his companions are squeezed flat and compressed into a block. Okay, this sounds pretty bad too, but hang in there, it gets better. The blocks are shredded into tiny pieces, which are washed and melted so they become the raw materials that can be used again. As if by magic, Bottle 3 is now ready to be reborn as something completely new. For this bit of plastic with such humble origins, suddenly, the sky is the limit.
Okay, so it turns out that there are different kinds of plastic. Okay, you see it, right? I've got, look, this heavier duty plastic, these are pretty thick, these are pretty thin. Have you noticed lately that water bottles are thinner? You know, they kind of collapse a little more easily. That's an effort to have less plastic in there, so we have less plastic being thrown away, and that kind of thing. That's why they've made them that way. Depending on the kind they are, so that you can look at anything. In fact, we could probably look at one of these pieces of plastic right here. I think they're supposed to be labeled. See, there's something labeled on the bottom of there. Which one? Can you tell, Ariana, what that says? This one says 5. What number is it? 5 on that one? This one says 5. This one says PET. That first one. Excuse me. Yeah, so yeah, we have polyethylene, polyethylene high density, polyvinyl chloride, polyethylene low, all these different kinds. Some of these recycle better than other ones. So if, let's say, we're on the conveyor belt's coming through and all these plastics are coming through, someone has to separate the one. They get an eye for it. They know which ones go here and there and that kind of stuff. And some of those can't be recycled at all. Okay, so some people would call the recycling thing a scam. I don't. I'm gonna have a question mark there. I don't. I think recycling is good. It's just not everything is recyclable. All right. So we just have to remember, it's kind of that pie in the sky. Oh yeah, let's recycle. It's very expensive to recycle stuff. And a lot of times, what we'll end up doing is selling all of our non-recyclable plastics as recyclables to another country, like a third world country, and tell them to deal with it, and they end up with a bunch of trash, our trash. You know, so it's not very, it's not good. So, once again, trying to move away from using plastics, go with glass, and if you can. Glass breaks. It's also pretty easily recyclable. glasses, and cardboard and stuff is as well. All right, so we're time here for lab. We're going to do a lab today called biomagnification. And we're going to be looking at kind of the way they, in the video, we're talking about the microplastics, how a creature might eat some, and then another creature eats that creature, and then the bigger creature, and then we eat the tuna, right? And there might be microplastics in there. We're going to do it with a insecticide that we've used. There was an insecticide that was developed back in the late 40s, early 50s, called DDT. And DDT is really, really great for killing mosquitoes. And this is good, right? Because mosquitoes carry diseases and that kind of thing. And so we used it, but then we found out that DDT never breaks down. It never breaks down. So that means it's in our environment forever. Okay, so we're going to look at how this happens in our lab. And I have a little paper for you to fill out here. Hidden dangers in food webs, it's called. So here it is. Many chemicals produced by industries end up in our waterways through dumping or runoff. Many of these chemicals can accumulate in the cells of organisms that live in the water. These chemicals then move up through the food chain and can be damaging or fatal to many types of organisms. Although the initial level of these chemicals might be low, the concentration of these chemicals increase as they move up the food chain. This is known as bioaccumulation or biomagnification. DDT, here's what it is called, dichloral diphenyl trichloroethane. Ugh. No wonder we call it DDT. Was first commonly used as an insecticide. Was the first commonly used insecticide. DDT was relatively inexpensive to make and had long-lasting effects. It enters aquatic environments by attaching itself to the surface of plankton, that's important, or accumulating in the cells of other organisms. DDT is harmful to many organisms as it attacks the nervous system of animals. Furthermore, it has an adverse effect, especially on seabirds. DDT prevents proper eggshell production in birds, which results in very brittle eggs that are easily broken. All right, so let's start our lab. And I'm gonna tell y'all what to do, and y'all are gonna do it. I'm signing off of the